Hello, friends. How do I sound now? Am I all messed up? Better? Okay, great. How's everybody doing today? Welcome back to the Comfy Org stream, and today we are going to dive into Flux Kontext LoRa Training. Um, oop, I've got my own audio coming back on me. There we go. Killed that. All right. So, yeah, basically, I don't know if y'all have seen what's going on with Flux Dev Context LoRa's, but they are absolutely crazy. So, also welcome, Phil. Um,
Howdy,
Why don't
howdy.
you just take over and tell people why they're so cool?
Yeah, I mean, for the first time I personally think the first time in the open source community and ecosystem, we have the ability to essentially pinpoint and train tools, right? And we've had LoRa's in the past, and it's like, yes, I can recreate Purz's face or whatever, but to do those like surgical micro edits, we really haven't had a neural network solution for this, mainly like masking and like a lot of the manual image manipulation stuff we're used to. So Flux Kontext LoRa's can really allow you to create crazy complex data preprocessors with as like a workflow in Comfy, and then essentially distill it down and train that whole process, like that whole process and that whole edit with the before and after, basically. Yeah, it's incredibly powerful.
Yeah, I've been going through a lot of the Flux Context LoRa's on Civit today, and they are really cool. It's funny. Some of them you can tell people trained the input images on GPT-1 or Open, O1 images because they got that yellow, dusty look to them
Hmm.
when they come out. But you just move past those. But yeah, man, I'll just show some examples of this stuff before we get into the nitty gritty of how it all works. But slide over here. There we go. Yeah, so here's some examples today. You guys would probably know the input images for these, but if not, I probably have them. But yeah, like these are all examples of someone who trained a LoRa to do something and then it really does the thing. And I did a lot of tests with you know doing these and then not adding the LoRa but having the same. Oh, the sound is bad.
I think it's crackly,
Oh,
just
crackly.
just very slightly.
Sorry, friends, let me try and fix. All right, is that any better?
Seems okay now.
Okay, well, let me know if I crackle. I'll just restart the whole system. Okay, but yeah, so I ran the images, just making the image and then making the image without the LoRa attached, but using the same seed and the same prompt to see what effect the LoRa was having. And it was having an absolutely massive effect. Let me pull up some examples from our chat earlier. Yeah, so this one like will turn people sort of like uh, I don't know what to call it, into frosted
Ir-
glass with like
Iridescent, I guess.
yeah, holographic. That's without the LoRa, and that's with it, and and that's the input image there. So let's see. Yeah, here's another example. That's the original image. That's with just the prompt. Turn this into a prism glass object, something like that, and then this is the the result with the LoRa. So um, what I can infer from this is that they trained a pair of images and then target images. So you have your what your image is like, and then what your image is like transformed, and you put those together and then train that. There and by the way, we're going to go into some stuff today with AI Toolkit, but it's going to be a brief overview in the sense that like there's a much better explanation of all this in the description below. Ostris, who made AI Toolkit, has a fantastic tutorial on all this stuff, and he explains, what's happening and why you're choosing the settings you're choosing. So if there's stuff we gloss over today or stuff that didn't make sense, please go watch that or just watch that to get a better understanding in general of what's going on here. But yeah, so it differs from a regular LoRa because with a regular LoRa, you're training one set of images with one caption. But with this, you're training a pair of images, so one side by side. And I should say, as a result, it takes a lot of VRAM to do this. I think
Hmm.
at 1024, yeah, I don't even know if you can fit that on 24 gigs
No, you
because they're side
cannot.
by side, right?
Yeah.
Yeah.
It's
So yeah, big train. But yeah, Phil will get into all this when we're talking about like how AI toolkit works, how you can make this work. But yeah, just to give you a basic idea, we're training a think of it like Phil said, like a Photoshop filter or an action or a thing, and then you're showing it like the before and after, and then it learns how to do the thing, and it's incredibly robust and smart and really good at it. So yeah, man, Phil, if you want to take over and just start showing off your stuff, that'd be awesome. I'll just
Yeah, absolutely.
slide over to the screen share there.
Where's my shares? There we are.
But also, that is to say, don't be scared about the VRAM thing because uh, there's ways to train this stuff in the cloud. So we'll talk about that too.
Hmm. Yeah. So, do you want to, Purz? Do you want to start with the data creation? Yeah. Sorry about that. Do you want to start
That's
with the
okay.
data creation or the actual training itself?
So what we're doing here is like
Slight
there's a
crackles again.
oh really? Jeez. Okay, you just take over, Phil. You do your thing. I'm gonna fix this.
Okay. Okay. No worries. Um, yeah, so like when training context LoRa's, because like they're a lot fundamentally different from how we used to train normal LoRa's, we need a pairing, right? And so my mind goes like it's very rare you're going to come across a pairing of data in like the wild or scraping the internet or whatnot. So we basically have to create it. And you can create like the data a multitude of different ways, right? The obvious being open up Photoshop, make some manipulations. Purz showed like a big head, Laura. I think you showed that, Laura. But those image manipulations, those pairings were made in Photoshop just by like enlarging someone's head. So for me, the first step for context LoRa's is really like creating a comfy pipeline that like just does a complex manipulation of an image, and the result is you get a beginning of the start and the end of that. So essentially an image to image workflow, and we can train that whole workflow down into a context LoRa, which I think is really fun. So here I have a basic example. I've shown this one in the past. We drop in an image. The first prompt here is it turns it into a plastic toy on a white background. The second prompt is creating the box, like the cardboard box. We'll tweak the title in a minute. And the last prompt here is put it on the shelf, right? And so the idea here is like this is a complicated three-step system, and we can run this system a multitude of times on a bunch of data, and we can create like a 20 to 50 pairing um, to essentially like create the whole data set. So I'm actually missing a piece of this puzzle. I'm going to quickly create a version of this workflow, like a pipeline rather. I'm going to create a pipeline that creates the base image that we manipulate. And what I mean by that is right now we're starting image to image, right? And so there's the pre-notion that like I need to have all the data, but I don't. So I actually want to create all the data in this example. We don't need that. We actually don't need that either. Empty latent, and we'll make it 1024 squared. And what else? V. And we're going to bring this down here. And so now we need to manipulate the prompt. So in this case, like all I'm going to do here is just put like people walking. And the idea here is that it's just going to generate the data for us that then we are going to manipulate with our workflow above. So yeah, put the seed on random, and then we're going to feed this image. We're going to encode it. Actually, we already have one. We'll put that right in there. And then so it'll render a picture of a person walking, and then it will manipulate the whole system down to them being a toy on a shelf. Like that's the whole workflow. And so now I feel like I'm going to tweak this title. I don't know, like, Purz, is your audio fixed yet?
Probably. Someone had a question.
Sure.
Are existing Flux LoRAs of any use with context? Do they work?
Yeah, so I've seen a bunch of stuff. I've tried maybe once or twice, and the consensus online is like basically do some like block subtraction and addition, like block merging, and then running the LoRa at like a 1.5 strength. And people have been finding that their existing Flux LoRas do something. I didn't have that much luck, and my personal opinion is it's just as easy to like train all the stuff back into a model once you have like the data. So
But yeah, just to reiterate, what you're doing here is we're generating the entire thing we need. We're generating the original image, we're generating the before image, the after image, and like getting it to the after image, even if it takes a couple revisions. So if this looks scary to you, it's okay. It's just multiple repetitions of the same process, and then it's just being stitched together. So yeah, like when you see these big workflows, it's usually one thing just repeated a bunch of times, and
yeah,
everything's
totally.
sort of plugged in a different way.
Yeah, we're gonna put this up here, and in fact, like we can break this up, right? This can be its own group down here. Oh, Control G is not working. Interesting. But anyway, we can. We didn't have a preview on this one. Interesting. Yeah, we can see it working through its process. I think it's still grabbing an image from somewhere. Oh, I see. These are not empty latents. So no, they are.
Hello, Julian. Welcome.
Hello. Sorry for the delay.
What up, MJ? Image size. These are 1024. We're encoding this picture. Why is that not?
Why isn't it turning her into a toy on a shelf?
Yes, that is the question, isn't it? Okay, there we go. Now we're talking. Okay, we're good. We're good. Okay, so basically at the end of this pipeline, I'm just going to do like an FL save images node. And honestly, any save node. But in this case, like I'm going to go create like a random subdirectory. Just put it in my downloads. And we'll call it toys. And then we'll, in here, create 2 new folders and call this input and output.
You'll see in if you follow Ostrus's tutorial for ai-toolkit, I think his is just sort of data and data target, but it's the same idea. You need to save the befores and the afters, and then whatever you call it, that's your business.
Yeah, exactly. We're just setting up the pairing, right? So this input image is actually going to be this picture right here, and then this one will just be the last one because that's our full loop. And so now, honestly, we can just set that to random, and we'll queue it, I don't know, 30 times. Let's do 20 times.
Three, 400 times, whatever.
Well, it's up to you, right? Like in this case, it'll transform people. It will skew towards turning people walking into these toys, right?
Toy.
However, However, like we need to augment the data more. So in a perfect world, you'd want to, yeah, do a bunch of objects, do a bunch of like different types of people, different types of styles of people doing things.
Yeah. Diversify your data set so you don't get the same thing over and over again.
Pretty much.
That makes sense. Yeah, this is great. So yeah, what trying to form my words here, they're not coming to me. What has been the coolest application you've seen so far of like Flux Kontext LoRa's?
Oh man. You know, I don't think the community has gotten super into it yet, honestly. I saw like the turnarounds, you know. That's a seems like a pretty obvious one. We've been struggling to synthesize data for a long time, so you know, people have been sitting on those data sets, but I don't know, man, like I really do think that something like this could be taken to like another level where you can train in entire styles or be more utilitarian and surgical with it. But I really don't think the community's taken it to the level yet. I don't know. What's your response?
I mean, Ostrus's big head LoRa is like the perfect example of why this is cool. You know, if you try to make somebody's head big with context, it kind of gets it sometimes. But if you use Ostrus's big head LoRa, it does it perfectly every time.
Every time, yeah.
Yeah, you got to repeat a task over and over again. I think this is the way to do that. We get a batch process, a bunch of stuff. Is probably the way to do that. Someone asked, are we using Flux Dev right now to make these images?
Correct. We actually are. 100%. Yeah, we're using Flux Dev. Yeah.
Context.
Yep, context.
So the idea here is you can actually use context. Like, oh yeah, I guess this is the point we didn't really cover. So this is a water wheel. We're starting with the image. We're using Flux Kontext and saying, do this thing to the image. And then you're using another instance of Flux Kontext, and you can send the image output to that and say, oh, and by the way, also do this other thing. And then you have your final thing at the end. So if your process takes multiple steps, it's okay. You can still get there. You just have to set up multiple versions of this request in context, because like Kontext's biggest strength for people who haven't used it before, it already kind of does this stuff on its own. It is an image editing model, like at heart, or a I don't even know what to call it.
Modifier, kind of.
Yeah, its ability to do things is greater than most other models. It's more in line with O1 and stuff. That's why these LoRa's are exciting, because yeah, there's Flux LoRa's, there's a million of them. They already work with Dev and they do LoRa stuff, but this is an actually like different kind of LoRa. So this is a very cool technology because you're almost training a skill into it. So yeah,
I think
I know I already covered this, but I wanted to kind of put that in context with why we're sort of doing it, because at the end of the day, this becomes a sort of water wheel where you can use context to make context LoRa's to do things better that you can make even more context LoRa's with it,
and I think
keep the cycle going.
Yeah, one way to see it with this is like it just saves time too. Once you have a LoRa trained to do the tests that you always do, like you said, repetition. You know, if you plug in that LoRa, it's going to do the thing without any effort, without any text. It's just going to do it because you're going to call for that little tool in your toolbox. And so I think it's just a great way to be more efficient and more streamlined. You know, by
totally.
LoRa's.
Yeah, 100%. Yeah, and you know, you pair that with all the automation that's come. I'm actually like rewiring this workflow as we speak, but you see it with a lot of the animation. What did I say? Efficiencies with the Nunchaku repo. You know, getting Flux Dev, you know, sub 10 seconds basically, and yeah, like you could have like an army of these little tool LoRa's in your arsenal to like make like micro edits, but really be artistic with it, right? Depending on this, you know, the toolage that you trained in. Okay.
Yeah.
So now I understand what's going on here.
Someone asked what video card you're using. Phil's using a big fat video card. But
Yeah.
to go back to what we were talking about earlier, you can't train a Flux Dev Kontext LoRA at 1024 on the 24 gig GPU. So you will have to rent something fat if you want to do it at 1024. But it's also totally cool to do a LoRA at 768 or 512. So we talked about it before, but the reason is if you think about what you'd be training into a model normally would be one image. But in this model, you're training one image beside another image, which is twice as wide, which is just going to increase the amount of VRAM it takes no matter what you're doing. So, yeah, just keep in mind this process requires, you know, more VRAM than just a regular. Like, I think you can train a Flux Dev LoRa on like 6 gigs of VRAM now. It's crazy. So, but yeah, yeah.
Yeah.
But you can rent a 5090 on RunPod for like 60 cents an hour. So you know, if you want to really do it, you can do it. But also you can rent like A6000s and stuff for Mike's still cracking, eh? Sorry everybody.
It is.
Yeah, this is weird. I'm trying to like get this thing firing, and oh, I don't have an image input. I'm so silly. It's literally just saving it and then looping through. Okay, we're good. Okay, cool. So I'm gonna in this circumstance, I'm actually gonna use a lot of like more of my abstract art, simply because I think it'll be more generalized to turn a lot of artsy images, not just like people, into these toys. So I finally got that running, and we can see like the first image here. Yeah, pretty interesting flat texture portrait, and we're turning it into a toy first. Now we got it in a box that just says toy, and this one is just going to put that toy on a shelf. Now, like, this is a pretty basic example. I definitely not my finest work, but the idea is there, right? Once the idea and the system is constructed, then that's where the fun happens. You just dial it. But yeah, so we got this running now, and like even this little prompt, you know, turning it into a toy is so fun, just like one off as is. Yeah, like this is so fun. Yeah, I want to 3D print that so bad. And you know, compared to the original image, it's like, yeah, it's 100%.
It's there, yeah.
Yeah. So I think like chaining these systems together, like, dude, that's so sick. Now, obviously, like the title and whatever, but it's captivating, honestly. And so, like, yeah, while we have this running, we'll take a look at that in a second. But let's verify input, output images. Great. So they're just saving through. And then, so over here, I have ai-toolkit. And so this is like the meat and potatoes of what we're doing all of this for. And Purz, I think, has his running on a Docker image up in RunPod. Yeah, like Purz mentioned before, we will need like a 5090, at least 32 gigabytes or higher to get 1024 resolution training. 720 works just fine on 24 gigabytes. I'm running on 48. I'm only training at 1024, so I'm not utilizing all of it. And yeah, so like the main page here, we've got, yeah, temperature readout. You can see my graphics card's actually under load because I am rendering these images locally. And the first thing we're going to want to do is just like create a new job. And you can think of this like the training, your config file, essentially, your config. And yeah, starting from top left, we got like the name of the LoRa, your GPU, CUDA ID, trigger word. As far as I know, like concept, when you use trigger word, the caption center trigger word automatically beginning of the caption. Okay, so we can provide our own captions, but you can also quickly add a trigger word here. Here we got the model architectures that we can select from. Honestly, he's really been doing work, man. Having stuff like Context, Dev, HiDream, Lumina, OmniGen, 1.5XL, and both WAN models under one
Yeah.
roof. Like
It's
it's
amazing.
powerful. It's so nice.
Nice UI
Super
too.
nice. Yeah, it's well thought out, and honestly, it provides us everything we want if we want to dive deeper. So in this case, like, yeah, we're gonna select context dev. We don't need to touch anything here. You can quantize the transformer if you want, which is the model weights.
Can you do a quick explanation of BF16, FP16, FP8?
Yeah, sure. So they're basically saved configurations, and there's just more data being stored in the model. There's some fancy math that goes into this, but they're basically floating point precision, and it's how granular of data we're allowing the neural network to store in decimal form, right? So we got like our positive one and our negative one, and the granularity in between. And for our weights. So that precision is essentially that. BF16 is a little more fancy. I don't know the math off by heart, but just know that, like, I think BF is in between FP and FP32. It holds a little bit more data compared to FP16. BF16 does. But yeah, all you got to know is it's like the amount of floating point numbers and the precision that the model can learn and retain data. So
it's in between. You're right, Phil, by the way.
It is in between? Yeah. Okay. Thank you for confirming that. Yeah, so pretty much going down, we've got save every. You can think of it like you're saving to disk a checkpoint of your trained LoRA. Max keep saves. So this one, actually be careful with, because basically what this means is as it trains the LoRA, it will only keep 4 of the save tensors on your hard drive. If you're the type of person that wants like the whole rainbow spectrum of files that you had just trained, bump that number up big time. If not, I don't know if -1 even, yeah, nothing. Yeah, bump it up as high as possible, honestly. I'll just keep mine at 4 because I've already done something like this. Yeah, then we got batch size, gradient accumulations, steps. Batch size is how many images you can run in a single, how many the images the network will see in a single go. You raise that number, it will definitely be higher VRAM, so be careful with that depending on the machine you're on. Gradient accumulation is actually like a performance thing. Optimizer, learning rates, weight decay. What Ostrich has set up for these parameters is actually a pretty solid starting point. I've never had to train a context model to 3,000 steps. I've been stopping it around like 1,200, 1,000 to 1,500 seems to be like the point in which I'm like, yeah, it's doing the thing. I'm happy with that. And then the next one that comes about, it messes up. And I'm like, okay, overtrained basically. Like, and it could be a hiccup. It doesn't necessarily mean it's immediately overtrained. Letting it go sometimes is like a good practice because you'd be surprised. However, like I let it go for 2 epochs more, and it was just like getting worse and worse. I was like, okay, this is obviously we're done. Yeah, I wouldn't touch any of the sigmoid, balance, or flow matching. You can if you know what you're doing. If you don't, do a little bit of research on these parameters. And same with these, I wouldn't touch those as well. Again, definitely more advanced settings that are granular. And then brings us down to data sets. And so this is where we can basically distinguish our data sets. So what goes here, because context came out and image pairing wasn't really a thing until it came out for training, the dataset folder we actually have to put here is the target, and we pair that with the prompt as well, the captioning file for it all. So this actually should be set to output, and we're still processing our toys, but yeah. So it should be set basically to the the B, A to the B of our image pair, we want B. P to be here, and we also pair our captions there. Here we set the resolution, right? So if you're on 24 gigs, 768 resolution will allow you to do it. If you're 32 gigs or higher, 1024. I haven't trained 1536. I'm assuming it's going to be past 48, but I haven't tested it yet. And yeah, we've got the sample every. So this is like our validation images, right? So resolution of that, and the type of, looks like sampler. And yeah, walking the seed. And so here we can basically kill a bunch of these. I'm only going to set 3 because that's really all we need for validating across a wide spectrum. And in our outputs here, we actually don't have captions, so we should add captions. I'm just going to add a text file and call it, we'll pair it with that. And inside here, we're basically going to just like add a caption. Actually, no, we can do this inside the toolkit, can't we? So under data sets, I'll make a new data set and call it toy output, and add images. Okay, so now we can click and drag images in here. So we'll just like let these trickle through. We're already at 13. I'll drag these 13 in for now.
How many images do you think you would need for this concept to take?
You know what? Let's actually browse the images. I don't think we've even seen a lot of the results yet. That's really going to dictate my answer here. Oh, interesting. It kept the resolution of the original picture. That's cool.
Some of these look a little sketchy. Maybe you want to check them off screen first.
Yeah, fair enough. Yeah, they're okay for now, but yeah, I totally get it.
Yeah.
I only have one
mindful.
screen. This is the problem right now.
Okay, well, yeah.
Yeah. But it looks, for a concept like this, because there's so much consistency of composition and even like the shelf that they're sitting upon. You know, I think this has to do with the fact that in our data augmentation setup here, we're actually locking the seeds. This one's random. No, that is interesting. So it looks like put this on a store shelf prompt for dev, or sorry, context, is pretty limited in its range to kind of like hallucinate new variations of that instruction. So that's like an interesting thing that we can keep in mind when playing with the model, because now that we're training the model, we have the ability to find those pitfalls and train them out, or train more variation in. You know what I mean? Okay, so we're gonna add these images here, and what do we got? I think we have like 15. That should be good.
Yeah, 15 feels good. Plus, it's double almost, because, or at least 1.5.
I'm really impressed with its ability to just like execute on that pipeline as is, right?
Yeah, it really does a good job of like maintaining the vibe.
Totally.
Yeah, it feels like you're in one store right now, and I'm gonna pick some toys from that one store. I love it.
Yeah, exactly. So now we can just be like, make this image. Yeah, this is where we get to dictate the instruction to context, right? So this is how we caption it, is as granular and is basically the instruction of it achieving this result. So we can get a little bit specific here if we want. We could say, we can make it super broad and say, make this image a toy, right? And it will just do this. Or we can kind of dissect the data a little bit and say, make this image a red toy on a shelf that says toy as the packaging. Yeah. So we can describe like the white shelf behind it. And the idea here is like by describing these elements in the image, we're essentially getting the ability to dissect what the model learns from it, in hopes that when we don't mention the white shelf, when we don't mention that the packaging is red, it gives us that flexibility. That's the idea. But so you can go one of many different ways in this example. But I think to keep it simple, we'll just say make this image a toy, because training in the token. So now I'm just going to copy these prompts, these captions all the way through. And let's see. I think that's good. Let's double check on our back end here. ai-toolkit data toy output. Great. So that looks good. And we need the toy input. So those were over here. What was the first one? The first one was the multicolored girl. Wait, they were here. Yeah, there we go. That's the list I want. And did we get that far? Did we get to that guy? We stopped at the girl with the magic. This one. So this one's Garbo. Cool. So now we can take these images. And now, sorry?
No, nothing. Just
yeah, it's all
following
good.
along.
Yeah, so now data sets, yeah, toy input, and error fetching files. Let's actually just make a new one. We'll delete this one because I think that's bugging out. Toy input. Add some images. So now we've got those. Nice, and they're in order. Perfect. Okay, cool. So let's configure a job. Training jobs. Yeah, we don't have any of them saved. So we're going to go new job. We're going to call this toy. We're going to set this to context dev. GPU's fine. 32 LoRA rank. Yeah, that seems good. And honestly, I've been having like good success with 250 as well. And yeah, 3,000 steps. I'll leave it at that. Everything here I'm leaving basically default because I played with it and Os just really did get like a good starting point. And then so for our prompts, let's get rid of all but 3. And in here we're basically just going to put make this image a toy.
Mm-hmm.
And then yes, so this is where things are a little weird. We have to add an argument with the image path. So we're going to put this space and then on all of them. And then we need to find the path of our images that we want to essentially validate. So the quickest way to do this for me anyway is like I'm just going to go to the inputs and no, this is actually where I want to give it images that it's never seen before. So then I can kind of assess its ability to do it on things it's never seen.
Yeah, just to touch on validation for a minute, what we're doing here is we're testing at each sort of where we saved it, in this case, every 250 steps. We're going to do a couple runs and have an idea of what the model's outputting at this point in the train. So what we're setting up here are the inference settings for that validation run that happens every time the model is saved. So when you train the model, you don't have to just wait until it's completely cooked to see what it looks like. You actually get, outputs while it's training to see if it's actually doing the thing or not, if you're wasting your time or not, or when it's done more specifically, because these models tend to finish well early.
Yeah, that's really the meat and potatoes of it. Is they do cook faster than you think, and we need to essentially figure out when we need to stop the thing. And the easiest way to do that is give it things it's never seen before. Where's copy?
The Ignite AI says it's not a bad idea to include some of the original images as well, just to see if it's doing the thing.
Yeah, you know what? That is a great idea. It's like a sanity check, basically. So I'm going to add that one in there. And I actually don't know if we need the quotes. Yeah, I mean, we'll see right away, basically.
I would guess
You only need the quotes. Sorry, you only
spaces.
need the quotes when there's spaces. Yeah.
Yep, exactly.
Okay, yeah, so there is spaces, correct. Great. So yeah, I'm going to create the job. And so now we've successfully created all the configs and training things. Until you hit create job, the settings that you tweak on Ostrus's tool are not, there's no state, which means if you leave that page and you come back, all the stuff you tweaked is gone. Just keep that in mind. Even if you're not done making the config, go to the bottom or go to the top and create the job, so that you can always come back to this pencil and edit it and then update the job. But if I'm in a training, if I'm in a new job and I change the name and then I leave and come back, the job is gone. There's no state. So keep that in mind. There's a lot of settings and it takes a lot of time to fill this kind of stuff out. So now that we've got our job created and it's right here, toy, I click the text and I think I'm going to go unload my models because I am training.
Not a bad idea. Yeah. As he slowly starts to break up and goes.
Yeah, exactly. Just instant CUDA. Okay, we're good. So yeah, I think. Hold on. Something feels. Yes, I forgot. We didn't set the data set. So we've got our validation, and we want to set this to the toy outputs. And the control data set is the inputs.
Makes sense.
Yeah, okay.
It's one of those things. It seems probably complex to some, but once you've done it once, it's probably like second nature.
Yeah, and then, you know, once you've set up your config once, you can always just go point like different data sets at it, you know, and just hit go.
Yeah, Late Night also says if you're editing a job you already made, you can click on the new job and it loads all your previous settings into the new job.
Oh, that's great. Yeah, that's awesome. If you've never run this before, it will download a bunch of models. Probably 20 to 30 gigabytes worth, just a heads up.
Yeah, the other thing is there is a setting in there, I think, that will save the entire checkpoint versus just the LoRa. You want to make sure that setting is off for the full checkpoint because otherwise you're going to save a 18 gig checkpoint at every step count. It's worth turning that off. So so what can happen is if you don't turn that off or if you don't delete them as it goes, training a LoRa could take like 200 gigs of space. You know what I mean? But it's not actually. All you need is the little tiny LoRa file that it makes. So you don't need to keep those giant checkpoints if they're being generated. You can just nuke that folder.
Yeah, I just noticed a little bug here. I copied the directory and not the file. So this is a directory. So I'm just going to swap that with this, double quotes.
Our friend Bennett, hello Bennett, would like to know how similar do the first and last pictures need to be in order for ai-toolkit to train effectively? In this case, we're doing Flux Kontext LoRa's, so this is specific to Flux Kontext, but I thought they needed the same structure, but this toy on the shelf example is proving otherwise. Bennett, that's the cool thing about this model. It's really smart, so we don't even know yet.
Pretty much
how far it can go, but we've been constantly blown away at what it picks up. So, this is what it looked like. This is what I want, and just try it.
Yeah. I mean, that's the thing, right? Is a lot of the simple instructions, put glasses on her head, change her hair color, like, make his shirt purple, like stuff like that. It's great that it does it, but the fact that it even does it, period, means that holy moly, the amount of A to Bs that you can create is near infinite. It's insanity. And they can be as grandiose or as granular as you want.
I guess another way to see the LoRa field real quick is
absolutely,
like with context, you can type how to go from A to B, while with LoRa, you can go from A to A plus B plus C plus D plus E plus F all in one go.
Yeah,
with
exactly.
effortlessly.
Yeah, and then that's the thing, right? Chaining them, holy moly! Like the power of chaining these things. I mean, pretty much just exactly what I did, right? For the toy. That's a really complex set of edits that I essentially just automated.
Yeah.
As someone who's like been a graphic designer for 12 years in a previous life, man, like that's insane. It would have taken me a day to make one of those toys in Photoshop correctly and believable,
And it might not even work.
Yeah, and it might not even look good. Exactly. Okay, so I think I got all the bugs worked out with my validation images. No.
Nope.
What?
Nope.
Is it the error. Quotes?
Quotes error, yeah.
Let's have a look.
It's definitely an error. There's a space and it doesn't like the quotes. So I'm going to take these images and I'm going to just drop them in my downloads. And the idea here is that I just need them to be in a directory with no spaces. And we'll take this one. So silly, man. Yeah, this is the things that you just like run into, right? So no spaces in the directory, beautiful. Okay.
No, still got spaces in that one.
Yeah, okay. Let's just get rid of it. Yeah. Oh, I see what you're saying. Okay, that's an easy fix.
Yeah, I mean, like this is all part of it.
Yeah, totally. I mean, it's hard to know like how someone created their project, right? And I could just go make a PR tomorrow. Like that's the cool part, right? We'll call this 3, 2, and 1. Beautiful. Okay, update the job and run it. And so here's the other thing, hopefully this goes through. Cross your fingers, everybody. The other thing though is they take a minute to train. I don't know, like it's quick, but not that quick. What's your experience been, Purz? I haven't been using 5090s.
I started to train one, and then it was going to take so long that I just killed the process. So,
oh really? Okay.
I've just been enjoying LoRa's through other people, and quite honestly, most of the research for this stream was done in that video I linked below. Because who better to get the information from than the person who made the app?
Totally. Yeah.
So again, like I said, like we're talking about this stuff, but if you want to really, truly understand it, check out that video below. He does a great job of breaking all the settings down and explaining, what you need to do and what doesn't matter.
Yeah, exactly. Yeah, and I mean, in our broad overview of the tool, it's really more about like the system that I put together to then create the data to train. That's really like the sauce here, because I know you guys in the chat are sitting on workflows that are just so monstrous, and when you open them up, you're like, yeah, it's so big and powerful, my workflow. Just take those outputs and train them, and like it almost renders the whole workflow like down into your own little your own neural network. It's
do they really sound like that?
I mean, I know there's some people who feel like that.
All right.
Purz.
If you
I
sound
know
like
you.
that, if you sound like that, raise your hand in the chat.
Purz, I know you when you build a system and you've got all the node lines perfectly straight, you're like, yeah, you know what? I'm gonna take a screenshot for me.
Yeah, that's how I get my dopamine. There's nothing else in life that'll do it anymore. It's just
Nah, you've
clean
got
line.
too many hobbies, man. Too many hobbies. Where are we at here? Okay, so we've generated one.
I see hands already.
That's amazing. Perfect. I knew it. See, I mean, it's okay. The first step is acceptance. It's fine. Okay, so
Here it
here
is.
we see
Here we
this.
have an absolute nightmare.
Yeah,
We have an absolute nightmare, but
I like the
what
texture.
we're actually seeing here is what the context model does with just a prompt. Right? This is sanity check number 1. So this is basically pre any data trained in. Yeah, the
So at that point,
inference.
you're just asking Flux Kontext for the thing with the prompt, but no LoRa.
Correct.
So we're
Yeah.
seeing what comes out of context when you give it just, make this a toy.
Mm-hmm. Yeah. You know, I don't even know if we'll get to the point where we get to test this thing. We can take it
Yeah,
that
no,
long.
that's fine. Like this is the process, it's all good. You can continue this on your own and see how it ends. But essentially, you take the LoRa you like the most, or the couple of them you like the most, and you slap them in your LoRa's folder, and you name them something that you won't forget the name of. And if you're smart, you'll put the trigger in the file name or leave a text file with the same name as your model that has the trigger phrase in it, because
Mhm.
you will forget the trigger phrase.
Yeah. Name it the trigger, basically.
Yeah, that may be the best tip.
Essentially.
And so, yeah, second sample. Also an absolute nightmare. This one's great. I love
It's
this one. Though.
that one's really cool. That one already looks kind of like a toy.
Yeah, but now the thing is, once this thing trains, toy quote unquote will be the whole box. The
Like a
package
toy
there.
on the shelf in
Yeah,
the packaging.
exactly. Yeah, Purz, we can jump over to you playing stuff because my machine's locked up now training this.
Yeah, sounds good. Can you use 2 images as the input? Like, for example, when you use 2 images as an input of ComfyUI? Yes, Grizzly, that's how this works. So you would think of it as one image beside the other image, like this. And then, this image is the beginning and this image is the end. So it's training what you started with and what you're ending with, and you're training the sort of, the function. So it's really cool.
Yeah, I want to
All
take
right.
it as far as like 3 images.
Yeah,
Just,
why not?
Rent a big graphics card and train in, whatever.
Yeah, let me pull up. What's a smart way of looking at my? I guess I'll just download it. Just running running my inference on a 5090. I rented on RunPod here. Output. There we go. Yeah. There they all are. No way to make those big, eh? No way to make those bigger, eh?
Mm-hmm.
Oh, that's pretty good. All right. Oh, does this work? Can I just scroll through them? Oh, great. Okay. So yeah, these are all input images. Great. They're all in the wrong order.
Yeah. Yeah, I mean,
Our friend Chris, So yeah, but the point is, all of these images were made with Flux Kontext LoRa's that were told to do something. Create a paper drawing, make a minimalist drawing, things like that. And yes, you can use Flux Dev LoRa's to do this kind of stuff, but there is a rigidity in style that you're getting from these that I haven't seen anywhere else yet. This Prism LoRa is very like specific. Like that being the input image and going to that is pretty crazy for me. I don't think a regular LoRa would kind of do it like almost
No.
pixel by pixel like that.
Yeah.
It would do something cool. Same thing with
look at
Chris.
that.
You saw that image of
one's
Chris,
great.
but now he looks like Silver Surfer or something.
Yeah.
Yeah, it looks like a trophy.
Some
Yeah.
mushrooms. He does look like a trophy.
Truly magic mushrooms. Okay. Just had to say.
Yeah. Yeah. And again, all this LoRa does is just make stuff, like a prism with light reflecting on it.
I think
I
the
did
real
the same
power
thing with the
though-
Comfy logo,
The real power though is that it's like a control net built in, right? That's
Yeah, exactly.
the appealing part.
It does the line art,
Yeah.
it does everything.
Yeah.
Well, no,
and
what I mean is like it just sticks to it, right? Like Purz said.
Yeah. Sometimes it doesn't, but it does tend to stick to it pretty good. Like, pretty impressive.
That's
It does it enough where your brain is tricked into thinking that it's perfect.
Yeah. Oh, it's so close, and
yeah.
it's yeah, I'm super duper impressed with all the stuff I've seen with the Flux LoRa's or Flux Kontext LoRa's. But yeah, how long is your thing saying it's going to take there, Phil?
I'm
no idea.
getting no. I can do the math real quick.
I'm going to make you do math live on stream.
Yeah, dude. It is what it is.
Yeah, the iridescent ones are really good. These the drawing ones came out really nice too. Yeah,
So it's about
I'm super blown away.
I'm at about an hour and 20 minutes for the first epoch.
Well, that is awful. Right on, friends.
Yeah.
On that note,
On that note,
it's worth it.
But you know what? We'll get some images that Phil made with this, and then when they're done, we'll post them in the Discord, post them on X and stuff like that. You can check out what we made with the LoRa, even if they're good or bad. We'll see. Make a little grid or something and show you sort of what it looks like at different steps. But yeah, I mean, again, this is just dipping your toes in it. If you want to go deeper, Ostris has compressed all this knowledge into like half the time we spent in a very digestible way. So please go to the description below, check out his tutorial on this, and go forth and make cool stuff. Tag us, and yeah, friends, thank you. And thank you, Phil. You did some heavy lifting here today, buddy.
loved it.
Appreciate you. Yeah, it was fun. It's something that I just want to keep diving into. So.
Mm-hmm.
Putting
No,
the
for
magic
sure.
touch.
Well, friends, make cool stuff, and we'll see you on Tuesday and then again on Friday. And we really enjoy hanging out with you, and we hope you enjoy hanging out with us, and we'll see you next time.
Happy birthday to Jeru.
Happy birthday,
Cheers.
Pixel Pusher. Right on, friends. Bye-bye.